Yeah. Hi, Professor. TA and the class of 5502. Today I'm recording this video for the final project presentation, and our topic is bank marketing to predict if the client will subscribe for term deposit. Like our group is group number 21, and we are four in member, and Geeta, Surya, Maulik, and myself, Vamsi, are involved in this project. Coming to the contents, we have respective roles like the workflow, the problem statement, and the conclusion and references. Everything is mentioned in the contents. And these are the respective roles, who all people involved in the project, and whatever they have done in the project is mentioned clearly here in the respective roles. Coming to the workflow here, collection and loading of data from UCI and Kaggle was done, and the visualization and insights from the database on different factors and variables are also done. Like the data cleaning and feature engineering was also involved, looking for NA values, label encoding, choosing relevant variables, trying, test, split, upsampling the data, vectorizing the data, and building different ML models, yeah, logistic, random forest, GB, etc., and evaluate the models. Turning the model using different hyperparameters and grid search and cross validation. And coming before going to the project in detail, we'll explain you what is bank marketing and why it is important for banks. Like in simple words, we can say that bank marketing is the design structure, layout, and delivery of customer needed service worked out by checking out the corporate objectives of the bank and environmental constraints. And why is this marketing important for banks is that the banking sector plays a key role in the development of the economy. Banks are now giving importance to the marketing activities to create awareness regarding their services to the public. Customer satisfaction is also important, so the banks are introducing new instruments and ways to attract the customers. Coming to the problem statement here, based on the census, personal details, financial details, and other marketing campaigns, predict if the customer will take the subscription for the term deposit. Overview, this is the classic marketing bank dataset uploaded originally in the UCI machine learning repository. Gaining the maximum value from a particular data collection is a challenging endeavor, since it is necessity through analysis of its many properties and accomplishing values. In this study, a bank's direct marketing data collection is subjected to several visualization approaches. With various feature engineering techniques being used different ensemble models to predict the outcome. Coming to the architecture and technology, we used Python for data processing and modeling. The system OS we used here is Linux. Environment on Colab notebook, and you can see the step-by-step user, the Google Linux server, Google storage bucket, processing on Google server. And coming to the workflow here, we have 4 steps: the data frame, transformer, estimator, and evaluator. Firstly, we'll be loading the data, then we'll try to extract the futures and train the model, and we'll evaluate. And once we are done, we'll be doing the testing. We'll be first loading the data in the testing, try to extract the features, predict using the modules, and evaluate that. That is how the Spark ML workflow works. Coming to the data set, the classification goal is to predict if the client will subscribe a term deposit, like the variable Y. We choose the data consists of 21 features and 41,000 plus entries, including personal and professional information of the client. Like here, we already mentioned the dataset link as well. Coming to the steps performed here, downloading and setting up PySpark in Colab, loading the data, short visualization on data, preparing data sets for training, building machine learning models, validation for comparison of different models using AUC. Like why we have used PySpark here is because the data is too high, and when we try to write the code in Python, it is taking a lot of time for running the code. So we used PySpark to normalize the workflow. Coming to the visualization, the visualization topic would be taken by my teammate Geeta, and she will start explaining about the visualization.
Hi, here is a glimpse of our data set. Dataset and here we perform the upsampling of the data because of yes and no contents are vary in many ways. So when it comes to why we have chosen upsampling, when we choose for downsampling, the actual data will be removed. That's why we have went to upsampling. And then here we can see some basic statistical aggregation of the numerical columns in between, like age of the customers are between 15 to 18 to 95. And then by looking at the distribution, we can see the distribution is rightly skewed, and most of the customers are between the age of 25 and 60. The most of, and also we can see the from this graph, we can see the most of the customers are married. And Maulika will continue the rest.
Yeah. When coming to pre-processing modeling, these are the steps which we are going to follow. First of all, we'll look for the NA values and make a cleanup over there. And then label encoding will be done, converting of categorical variables into some numeric values. After that, we will choose some relevant variables and as the upsampling process. After that, depending on the data that we need to process, we'll be splitting those data into train test split. And after that, vectorization of data will be done. That means converting the data in the form of arrays. And then so yeah, after pre-processing we are using just a few of the models. In that logistic regression, decision tree are two of those. So these are the basic ones which we used to perform. But now in our project we are using these ensembling models as well. So in these ensembling models, random forest is a regular one which we followed in normal times. But in addition to this, we are using the gradient boosting as well. It is a machine learning technique for both regression and classification models, which produces a prediction model in form of ensembling of weak prediction models. So yeah, in addition to the decision trees, to get it boosted with the weak prediction models, we are using gradient boosting. This is the main concept in our project. So after processing all of these models, ensembling models and all, these are the results which we have. So when we consider all of these results, gradient boosting is having the highest one. So this is the best model. Therefore, we can go ahead with the gradient boosting with the best parameters. So yeah, this is the one.
Hi all, this is a code we have used, and we have set, we have set PySpark in the Google Colab, and we also load the environment like OS, and we had mounting the drive, like our data set was in our My Google Drive. So we just need to change the Google Drive like to get the data. And once we give the permission to allow the Google Drive, we can get the data. And this is a overview of our data set and consists of what are the features. And let's say, we can see the before before upsampling the data and after upsampling. And this is just a pair plot which we have used to compare. And these are the basic models which we have used and which were set by our teammates in the PPT presentation. And so if we see to the output, we can see like we had get the ROC for gradient boosting, we get 0.9125 something. So for that we can we can conclude that ROC score for boosting algorithm is slight higher than the others. It converts weak learner to strong learners. So this is the basic code and which we have attached in the report as well. Thank you.